Welcome back. In this section, Section 4, we're going to be combining the techniques from the previous two sections, supervised learning and unsupervised learning, in order to make inferences and make predictions that will allow us to make better decisions. The set of techniques we're going to talk about fall under the category of semi-supervised learning. So let's start there. What is semi-supervised learning? Semi-supervised learning is a combination of unsupervised learning and supervised learning. Specifically, we assume that we have a large data set that has some structure to it. Just like in unsupervised learning, we can analyze that structure and find ways to summarize the data and understand the relationships between different points in our data set. In our data set, we'll be missing some values. We don't have complete information for all of the data points, but we do have that information for at least some of the data points. This will be called the labeled subset or the supervised subset of the data. And the problem of semi-supervised learning is how do we extrapolate that labeled information to the rest of the data set? How do we take that supervised subset and extend those labels or infer the labels for the rest of the data? A simple recipe for solving the semi-supervised learning problem goes like this. Pick your favorite clustering algorithm and use it to cluster the data. Then for each cluster, look to see if there are any points that have that missing information, if there are any points that have those missing labels. If you find one, label the entire cluster with the same label as that data point. Now, you could run into problems here. One is that some clusters don't have any data points that are labeled. In the case that the supervised subset doesn't have anything in that cluster, just look for the nearest supervised point, say, and label the entire cluster that way. And the other problem you could run into is that you have supervised points that disagree with each other. Maybe 3 points in one cluster say that it's one group or one category or has one value, but then one point says something different. In that case, you should probably just go with the majority opinion. So you can see here in this recipe that we're combining unsupervised learning with supervised learning. The unsupervised learning is discovering the structure in the data, and the supervised learning is extrapolating labels in a way that leverages that structure. This is what makes it semi-supervised learning. The problem of taking some subset of labels from the supervised set and extrapolating them to the rest of the data is called label transduction. What we've just described is a label transduction algorithm. There's a couple of other ways that you can do this, and I'm going to mention one right now called label propagation. The idea here is a little bit different. Instead of clustering initially and then propagating labels all at once, we're going to propagate labels one at a time to points that we're very confident should have the same label as points that we've already labeled. So in this example on screen, on the left there are two circles. Most of the points we don't know what their label should be, but we do have 2 points, one in each of these big circles, for which we know the value. If you can see them, they're on the right side of the circles. The label propagation algorithm works like this. Imagine that we're doing supervised learning, and we only have these 2 labels. For each point, let's predict what its label should be, but let's also estimate its confidence that it's been labeled correctly. So in this setting, if we were to use, for example, support vector machine, some of the points would be very confidently labeled one way, some of the points would be very confidently labeled another way, and we could choose the point that has the highest confidence that its labeling is correct. We label that point with the appropriate label and add it to our supervised set, and then we do this again. We build a classifier, we ask which point is most confident of its classification, and then we label that point, and so on and so forth. Support vector machines may actually not be the best classifier for this set of points. You could also imagine something that just looks at how close it is to each of the labeled points, and it estimates its certainty based on the ratio between its closeness to the label that it's closest to and the closeness of the nearest point of a differing label. Regardless of what your classification algorithm is or your method of measuring uncertainty, you can eventually label the entire data set. And this has the nice property that it's easy to plug in known supervised learning techniques in combination with this propagation step, where the previous technique, this cluster then label, allowed us to use a wide variety of unsupervised learning techniques. This allows us to bring to bear a large collection of supervised learning techniques, but both strategies are ultimately solving the same problem. In fact, the way that the labels are propagated ends up looking a lot like what you would get if you did some kind of agglomerative clustering like we saw in the previous section, and then did the label propagation